In this video, we will finish up with a few more examples of word problems that can be solved using linear equations. Example 4 says that 4 friends use an online coupon to get discounts on concert tickets. They spent $312 for the 4 tickets. The question is, what was the price of one ticket without the discount? And we can see sort of their receipt here. I'm going to scroll down a little bit and we'll solve this underneath here. So this is going to use the format blank minus blank equals some kind of result. We're going to say that the price of 4 tickets without the discount minus the discount equals the price they had to pay. So they're already showing that the discount for each ticket was $15. So the discount for the 4 tickets was 4 times $15. I'm going to write that discount in this blank, 4 times $15. Over here, I'm going to write what they would have paid for the tickets without the discount. And there are 4 tickets, but we don't know what the price of the tickets was before the discount. We can use a variable. We could use the variable X, but since we're talking about ticket prices here, I guess I'll use a variable P. Change things up a little bit. To solve this equation, all we need to do is simplify a bit. 4p minus, well, 4 times 15 is 60, and that is equal to 312. Solve this in 2 steps. First, add 60 to both sides. Now 4p is equal to 372. Come over here to finish the problem. 4p equals 372. I will divide both sides by 4 to cancel out that 4. And I'll find that the price of a ticket before the discount was $93. 372 divided by 4 is 93. Same 4 friends buy tickets for 2 shows on consecutive nights. They use a coupon for $5 off each ticket. They pay a total of $416 for 8 tickets. Write and solve an equation to find the original price of the tickets. Now, bear in mind, there are 8 tickets this time. So pause the video and try to solve this one yourself. Now let's see how you should have solved this problem. Again, we're going to take the price or the amount paid for tickets before the discount. We're going to subtract the discount, and that leaves what the 4 friends paid, $416. The discount this time is $5 off each ticket, but there are 8 tickets that we're taking $5 off. The price before, we don't know what that is, but we know that they paid that price for 8 tickets. So we'll write 8 times the variable. Now let's solve it, simplify and solve here. This is 8p minus 40 equals 416. I'm going to add 40 to both sides because there's a number being subtracted from the variable side. Add 40, add 40. Now 8p is equal to 456. And finally divide both sides by 8. And we'll have the price of a single ticket before the discount. 456 divided by 8 equals 57. And I do this division using a calculator. I just did it earlier. Let's go on to the next example. LaTanya will walk her bike from her house to the bike shop, which is 1.5 miles from her house, to get the bike fixed. She expects to wait 30 minutes for the repair, then she will ride her bike home. The question is, can she be home in 1 hour? And we're going to use this to illustrate a relationship here. Distance is equal to rate times time. So distance divided by rate is equal to time. I'm going to try to add up the amount of time this is going to take and see if it can be less than or equal to 1 hour. So first, Latanya walks her bike to the shop. She has a distance of 1.5 miles and she has a rate of 3 miles per hour. It shows that down here in the illustration. She can only walk the bike because the bike's broken. She can't ride it. She walks at 3 miles per hour. So distance divided by rate. Well, 1.5 divided by 3 is equal to 0.5. That is half an hour. It says she's going to expect to wait 30 minutes for the repair. That's another half an hour. So can she be home in 1 hour? No, she's going to be at the bike shop at the end of 1 hour. Even if she can ride her bike at 10 miles per hour, there's no way she can get to her home in 0 time. So our answer to this question is no. She cannot be home in 1 hour. Let's look at a similar problem here that's going to involve distance over rate to calculate some times. So Latanya leaves her house at 12:30 p.m. and bikes 12 miles per hour to Marta's house. I guess she did finally get her bike fixed. She stays at Marta's house for 90 minutes. Both girls walk back to Latanya's house along the same route at 2.5 miles per hour. They arrive at Latanya's house at 3:30 p.m. How far is Marta's house from Latanya's house? I'm going to move my picture out of the way here so we can see, again, the relationship we're going to be using. Distance divided by rate gives us a time. And we're going to fill in each of these blanks with the time it takes to complete one part of this afternoon here. So first, I'm going to take her bike ride to her friend's house. She has a distance of, we don't know, whatever the distance it is from Marta's house to Latanya's, but she has a rate of 12. So I'm going to put that over 12. Then she's going to stay at Marta's house for 90 minutes. 90 minutes is 1.5 hours. So I'm going to put in the second blank an amount of time, 1.5 hours. In the third blank, I'm going to again calculate a time doing distance divided by rate. So again, she's going to go the distance to between Latanya's house and Marta's house, but this time she's walking with Marta, not riding her bike, so going a lot slower, 2.5 miles per hour. So this is a time, this is a time, this is a time. It all adds up to some total amount of time. Well, remember, she started this thing at 12:30. She got back to her house at 3:30. That means it was a total of 3 hours. Now, we're going to try to solve this equation. And when we find D, we'll know the distance from Marta's house to Latanya's house. I see an equation here that has fractions. In the past, we have used the distributive property to clear our equation of fractions. But in the past, I've only seen a single denominator. Now I have a denominator of 12 and a denominator of 2.5. Well, here's what I'm going to do. I'm going to distribute both of those numbers, 12 times 2.5. And let's talk about what happens in each case. If I multiply 12 times 2.5 times this first fraction, the 12s will cancel out. And I'll be left with not a fraction, but just 2.5 times D. If I multiply 12 times 2.5 times 1.5, I will get 45. I did that earlier on a calculator. And finally, if I multiply 12 times 2.5 times this fraction D over 2.5, the 2.5s will cancel out. And I'll be left with 12 times the D. Well, that takes care of that side of the equation, but I'm multiplying both sides of this equation by 12 times 2.5, and 12 times 2.5 times 3 comes out to 90. So here's the equation I need to solve. 2.5d plus 45 plus 12d equals 90. Well, let's use our equation solving flowchart. We're going to combine some like terms. Those two like terms will add up to 14.5d. We still have a 45, and this is all adding up to 90. So I'm going to subtract 45 from both sides of this equation. Leaves me with 14.5d is equal to 45. Finally, I'm going to divide both sides by 14.5 so I can undo that multiplication. Divide by 14.5, divide by 14.5. And this is another one that I worked out earlier on a calculator. 45 divided by 14.5 is 3.103. That's approximate. The decimal actually goes on beyond that, but I'd say we could safely say that it's about 3.1 miles from Marta's house to Latanya's house. 3.1 miles.